Buongiorno, come state? How are you? Good. Do you have any question for me? Very hot here inside. Yeah. I think I will better take my sweater off. You should have all the videos so far available on YouTube, my website. If you experience any problem, let me know. Also by email, if you have any question, any remark, just let me know. So, first, before I start, let me check for a graph that I wanted to show you updated. So, global greenhouse emissions, our world in data. Let me check. Okay. Let's see. I have to find the graph, the right graph. Let's see. This one. Okay, so let's forget to translate our working data. Okay, I think I agree. Okay. Okay, good. I wanted to start with this graph, but first, let me say one thing. Today, the lecture that I'm giving today is linked to my website, the website that you know since this morning. It was not there before than that. And the reason is that this is a topic that I decided to include this year for two reasons. First, because maybe that I am wrong, but by looking at your faces last time, I thought that I should better move rapidly from engineering to health sciences. But the real reason why I also decided to make this, to include this new lecture, is that, as I mentioned to you, I discovered only recently that there is some overlap with the course of ecosystem health that I think you will attend the next year. For sure, it is a course of the fourth year. I'm not sure if it is compulsory for everybody or not. But in any case, I have to remove one lecture, and therefore I included this one. I would like to start with this graph because it gives to you a global picture of the origin of the global greenhouse gas emissions. So as you see from the title, it's showing the global greenhouse gas emissions by sector. This is from our working data, and you may have seen, I just Googled global greenhouse gas emissions, our working data, and I got it. There are several versions of this graph. This is a kind of a pie graph, but there are also linear ones. But the essence is, I think it's better taken from this. So I think it is very interesting because we often talk about the impact on climate of greenhouse gases emissions, anthropogenic ones, and we assume that we know everything of them. Actually, they are quite difficult to be estimated. So one thing that we can measure is the CO2 concentration in the atmosphere, but then to understand where the CO2 comes from, it's not easy. And therefore we use models to make these estimates. And actually, in order of magnitude that I can give to you, in the overall budget of CO2 emissions from the Earth, solid Earth, to the atmosphere, the anthropogenic emissions basically take about one quarter, 25%. There are many other emissions from vegetation, from the oceans, as we learned. However, clearly one quarter is still very significant, and therefore it's interesting to try to understand where these emissions come from. So what you can see here is that energy is responsible, energy production. Energy is not only electricity, energy is energy, okay? And it's not easy to give a definition of energy, but let's say that energy includes electricity. Energy is what moves, as you know, the bodies, what moves, it's the fuel to dynamic systems. Okay, so basically energy production takes about three quarters of our emissions. Energy production includes several subsectors, and I'm not sure if you can, yeah, but you have the screen also close to you. So you will see that, for instance, road transport takes about 12%. And this is, maybe you expected this percentage. Actually, many people think that road transportation is responsible for more than that. Actually, it's not really a significant part of our emissions. And another thing that very often is not well taken is aviation. So aviation is responsible only for 2% of our emissions. So you understand that these percentages, basically, they outline priorities of intervention if we want to reduce it. And energy also includes energy used in buildings, which is about 18%. It's much more than aviation, and it's a bit more than road transportation. And in particular, you can see the split between commercial buildings, 6%, and residential buildings. And then there is shipping, aviation, road transport, industry, and several types of industry. Basically, energy for the industry is responsible for about 1/4 of our emissions, 24%. Okay. And then we have agriculture. Agriculture is a big contribution. It's about, let me see, 18%. It's a big contribution, actually. And then we have the industry. And industry meaning emissions not related to the energy production, because of course there is also a part of energy use in industry, but the emissions from industry not related to energy is about 5%. And then there is the waste. Waste treatment is about 3%. Okay. And why I am showing this graph? Because today I want to introduce this topic of climate friendly and climate proof health systems. And you will see that the health system is responsible for a significant part of our emissions through the use of energy, because energy used in buildings may include, I think it includes also the energy used in the health system. Of course, I'm not 100% sure of the details. We should look at our working data. But in any case, you will see, I will show you some data. It's the health system is responsible for our emissions. You may think that this is not a priority problem, okay? Because indeed decarbonization, we know that it's a target that is on the agenda today of several administrations. Today, more in Europe than the United States, as you know, because the United States a little bit put aside this objective. And also we are realizing that decarbonization is taking a lot of resources, and therefore, indeed, the rush towards decarbonization that was started in Europe with the Green Deal about 6 years ago probably is about too quick. Because indeed, decarbonization is a good target, but on the other hand, I highlighted already, and you know that the effect of decarbonization of climate is subjected to some uncertainty. So you may think that, it's less than a priority, and to some extent I may agree with you. Okay, but on the other hand, there is one thing that you have to keep in mind. Reduction of emission is strictly related to the sustainability of a given mechanism. So again, sustainability is indeed a priority, because we know that sustainability of the health system is a priority. And in Italy, today we are experiencing some difficult times in terms of public funds and financial resources of the government, of the state. And we know that there are cuts in the health system, which we know what are the consequences, what is the impact on the population. So sustainability of the health system is really a priority. So if you reduce the energy consumption of the health system, you get to target with decarbonization. And as I said, you may think it's not so priority. But on the other hand, you also give a relevant contribution, because we will see that energy consumption in the hospitals is really huge. You give a contribution to making the system more sustainable. And remember, very often when we have some problems of sustainability, we claim for more funding. That's correct, but on the other hand, there is to say that as we say, the blanket is not is too short. So claiming for more funding is something that, unfortunately, can be successful for everybody, for every sector of our organization, of our societal organization. So it's clear that we need to tackle the problem with an integrated approach. We should for sure claim for more funding, and I am claiming for more fundings to the university system, not every day, but every other day at least. And I am claiming with the rector, I'm claiming with the government. When I can sign petitions, I do that. But on the other hand, we have to make an effort to reduce our requirements, because it's an integrated approach that we need. Okay, so I think that looking at international experiences in terms of making the health system more sustainable is an interesting problem. It's a very interesting also experience to look at other countries, how they resolve. And this is the purpose of this lecture today. So after this introduction, I just wanted to let you know that the link is here, okay? And you see that I put in red climate-related diseases. In red, I think I have written somewhere. No, I have to write it. Red means that I didn't present this link in the room, in the classroom, okay? I left it there because it may be useful for you, okay? Next year, you will get some more information in the course of ecosystems, but on the other hand, it's here, and I decided to leave it there. But let's now click on this new link, a perspective on climate-friendly and climate-proof health systems. So far, I introduced only the meaning of climate-friendly. What does it mean, climate-proof? It means an ecosystem that is resilient against climate shocks. And this is another topical issue nowadays, because recently we experienced some disaster at the international level, and in some of the cases, the health system didn't react properly, or in a way, let's say that it was also put in crisis. And the last thing that we want during a crisis is that the crisis is extended to the health system. So the health system is one of the parts of the societal organization of our society that we really need to make resilient. You learned how to get data, we discussed how to get data about the future climates. So we already introduced and discussed how climate predictions are obtained, and now we need to pass to the actions, the solutions to the problem. So on the one hand, we talked about the drivers that can make the health system not resilient. And now today we try to talk about the solutions. And I do that at the bottom of this lecture, you find the PowerPoint, and let me open it. It's already here, okay. And let me start the presentation. Let me see if you see, yeah, you see full screen. So what is a climate-friendly health system? Is a system that both reduces its contribution to climate change and also adapts to protect health under climate change. So basically, when we say climate friendly, we include both the categories. And a climate friendly health system is also a health system that is optimized in order to be more sustainable. Because, as I said, energy consumption is strictly related to reducing our CO2 emissions. And this is why I started with the pie graph, because you can see from there that energy is indeed saving energy is the same thing than saving our emissions in terms of our emissions. You know that today we talk about renewable energy, and sometimes from the media we listen like some claims that in a few years we rely entirely on renewable energy. This is a dream target, and renewable energy, unfortunately, will never allow us to be self-sufficient for energy production. What is the reason why renewable energy is limited? The main problem is that it's cannot be tuned. Renewable energy is produced when there is the sun, when there is the wind, and we cannot push a button and say, okay, I need wind energy today, and you push the button and it starts. Conversely, fossil fuels, burning fossil fuels, is something that you can tune. You can just produce the energy when you need it. Another example, which I think is significant, is hydropower. Hydropower indeed can be regulated and is to some extent renewable. It's why I say to some extent, because once that you turbine it, yes, it is renewable, but before the water comes back into the reservoir after flowing into the ocean, evaporation and rain, you understand that it's renewable, but not in a very short time. But hydropower indeed can be regulated, can be tuned. But hydropower accounts for about 3% of the global energy production. And the fossil fuels still account for about 70%. And renewable account for about 22%. And the reason of this percentage that is still limited is, again, the fact that it cannot be regulated. And remember, energy, it's very complicated to store. You cannot store energy easily because batteries, what's the problem with batteries? They have a limited capacity. They are expensive also in terms of CO2 emissions. And then displacing them after their use, it's a problem because they produce a lot of waste. And therefore, it's not a solution. A very good solution to store energy is indeed hydropower because, you store the water upstream and that's energy. And in fact, hydropower is used to compensate the lack of other renewables. So when you don't have solar energy during the night, you use hydropower. We use hydropower. When there is no wind, we use hydropower. And when there is excess of solar energy or excess of wind energy that cannot be stored, we use it in order to pump back water into the reservoir. This is common practice. So basically, we turbine water from the reservoir, from the dams when we need it, and when there is excess of renewable energy, we use it to pump water back. So we accelerate the hydrological cycle by using the renewable energy. But still, it's a bit of a problem. And so basically, keep in mind that within our lifetime, we will not be able to, or let's see, within my lifetime for sure, yours maybe, but I don't think so. We will not be able to be to rely only on renewable energy. This means that there will always be some CO2 emissions related to energy production. So when we say climate-friendly health system, we can also say, in simpler words, that it's a system that is resilient and sustainable. And so basically, we have to make it sustainable in terms of use of energy and make it resilient against the climate shocks. How can we do that? How can we adapt our Earth system? How can we make our Earth system more efficient? Classically, the classic approach divides the actions, adaptation, and mitigation of climate change. Adaptation means adaptation to enemies, maybe also adaptation to earthquakes. These actions are divided into two big categories: structural intervention, structural solutions, and non-structural solutions. And here you can see a third one, which is the operational solution or measure. They are called here measures. And usually in engineering, we incorporate the operational measures in the non-structural. But let me explain what are these three categories. Structural solution means that we change the buildings, we build new facilities. Basically, we need new structures, or we need to adapt the structure. We work on the structure, on the hard structure of the Earth system. Non-structural solutions work on the organization. So non-structural solution may be to optimize the workflow of the healthcare, maybe to optimize the education of the operators. And so these are solutions that require a change in the organization, but the structure of the system remains the same, the hard structure. And then here, with operational measures, basically they identify within the large class of the non-structural solutions, those that refer to the operation of the system. So those that refer to the day-to-day work. So, for instance, if you use reusable materials in the theaters or operation room, I'm not sure if you use the term theater for the operation room or operation room. Operation means the room where the surgery is actually done. And so if you optimize the reuse of the material, as we will see, this is a possible solution. This is an operational measure. If you rebuild the theater, then it's a structural solution. And if you, in a way, change the policies related to the admissions of the patients, if you change the therapies in order to optimize them, we can classify it as a non-structural solution. So here you see other examples: robust preparedness plans, and these are non-structural and operational strategies. Early warning systems, for instance, for climate events. This is a non-structural measure that reduces the load of the health system, because you reduce the number of people affected in a way that their health is undermined. And there is an extensive literature on that. I make reference, I mean, if you look over the web, there are a lot of reports, especially after the pandemics. After the pandemics, the issue of making the health system more resilient against these extreme events, and pandemics is an extreme event that to some extent may be related to climate change. I don't think so, but in any case, it can be related to climate. So after the pandemics, there has been really a big increase of the literature, a lot of contributions. And this is the third time that I deliver this course here. And I noticed even in 2025 a large increase of contributions related to the resilience of the health system. This is also another motivation that suggested me to include this lecture. I selected, in order to give you this lecture, two references. The first one is on the screen, is titled Green Surgery. And the title, I mean, is something that I think it's a bit misleading because, I mean, energy saving is part of the green strategies. On the other hand, you know, this term is a bit not very efficient to get the trust of the public. So the reaction of the public, when you talk about green surgery, the first reaction is, let's make the surgery safer. And okay, if it's green, it's an added value. Actually, if the health system is saving energy, is more sustainable, it becomes safer, it becomes more effective. So I don't really like the use of the term green because, I mean, it's a problem with the trust of the public, that basically the public tends to associate the green strategies as to strategies that are not very efficient and expensive. So anyway, and the green surgery, reducing the environmental impact of surgical care. And this is by by the UK Health Alliance on Climate Change, and it's including this alliance several hospitals, and therefore there are several case studies reported here. This is the first reference. A second reference that I will call into play later today is referred to experiences in Japan, and it's you know that Japan has an health system that is particularly resilient against disasters because they are subjected to many of them. They are subjected to strong earthquakes, they are subjected to tsunamis, they are subjected to flooding, and therefore looking at their experience is interesting. On the other hand, there are many other contributions, and so you can, if you are interested in the topic, of course I cannot expand too much. If you are interested in the topic, there are other references that you can easily find. Okay, so first, here there is a graph that I hope you can understand, which I think it is interesting, which refers to the total annual spend of the National Health System of England. About 27% of the expense is related to surgery. And the graph here splits among the different type of surgery interventions. And you can see that the most expensive by far are the interventions related to obstetrics and gynecology, general surgery, and trauma and orthopedics. And then there is ophthalmology, urology, otolaryngology, and then you go on the left to the lower one. And here there is an attempt to split this cost in terms of the different stages of the treatment. So first appointment, follow-up appointments, and they estimate the cost of these steps. Outpatient procedure. Outpatient means that the patient is not recovered in the hospital, and the day case means it's recovered one day. And elective inpatient means, but I think you know better than me what it means. It means that they are scheduled to enter the hospital, and the non-elective are those that get into the hospital without a scheduling, without a prior scheduling for an accident or for many reasons. And then there is non-elective short stay, regular day and night admissions, and it refers to the years to the biennium 2019-2020. I think it is interesting, and it is interesting to notice that it's 1/3 of the expense, about 1/3, or a little bit less than 1/3, is related to surgery. So this highlights that saving energy in surgery operations is potentially can provide a very good contribution to get the target, to make the system climate friendly, which means also more resilient. Okay, let's see what are the basic recommendations. I will present some basic recommendation of this report. I think the UK experience is particularly interesting. I will present some basic recommendation and then a couple of zoom over a couple of case studies. First of all, what the report does, it indeed provides general recommendation to reduce the environmental impact. Environmental impact, as you will see, means energy consumption. What are the main contribution, I mean, the main sectors where the recommendation refer to? There is the single-use items, so the items that are thrown away after their first use. This is indeed taking a lot of energy. Energy consumption is taking a lot of impact, let's say, energy consumption, and anesthetic gases. And this is also something that is producing a huge impact. And basically, you can understand what the solutions may be, okay, in these three sectors. But let's look at the detail. So first of all, you see here on the right a case study where they studied in an hospital, and the hospital is the Nuffield Health. The Nuffield Health is a charity organization that is managing several hospitals. So is involved in the management of several hospitals. They refer here to the theaters, And the intervention is very simply switching the ventilation from a low-powered setback mode to off during the night. So when the theater is not used, they just switch off the ventilation. This is complying with the national guidelines of the health system, and these national guidelines are here indicated with the acronym HTM 0301. So it's complying, it's no problem. Of course, it has to be switched on time, okay? And the results are amazing because, as you see, okay, let's look at the tons of CO2. For each theater, we get a decrease of about, the range is 36 tons of CO2. And the most interesting part is the saving of the money. So the money is estimated. I mean, you can convert the pounds in euros, more or less. It's not really 1-1, but very close. And it's about 30,000 per theater per year. And this means that if the practice is promoted at the national level, it could save about 90 million per year. So 90 million. And I guess that in Italy would be probably a bit larger, okay, a bit larger because England is smaller than the Italian context. I'm not really sure the number of operational theater that they manage, but I mean, in any case, it's a relevant saving. And indeed, more than 90% of the energy that is used in operating room consumption relates to heating, ventilation, and air conditioning. And so clearly, actions of this type may play a relevant role. Why this is not done? Of course, it's not done because we want to keep the operational room always ready, and because of course something may happen, and but on the other hand, you can easily understand that with an adequate planning, we may keep some of the operational room indeed conditioned and ventilated, but not all of them. So indeed, this requires an organization. Requiring an organization means that we need to identify a responsible person for the organization. So you understand that there is a chain of changes that need to be introduced, that indeed it's not easy to activate. And in fact, after the publication of this report, which was published 2 years ago, a relevant discussion on the web started on implementation, because, you know, another key step of finding solution is the implementation of the solution that we identified. Okay. What about the single use of surgical products? About 2/3 of the carbon emissions from theaters is related indeed to these single-use tools like operating instruments, gowns, and drapes. And therefore, another case study, let me see if it is clickable here, because it seems that it's clickable. Let me see. Okay, so this is one of the case studies of the Green Surgery report. And this is the list of the case studies. And you see here, it's interesting to look at the titles. Let me increase the size. So the sections are divided in a section dedicated to reducing the need for surgical care. And there are case studies. And surgical care pathways, we will see something related to that. And you see that changing the pathway means that you have to change the way in which the therapy is applied. So it requires a rethinking of what we do. For instance, a change, I will show you the information related to that. They found that reducing the inactivity after an operation to the heart, so a cardiac intervention, reducing the inactivity, so promoting an early recovery, allows to shorten a lot the duration of the therapy without compromising the effectiveness of the recovery itself. And this allows to make the system really more sustainable. And you see the other examples: carpal tunnel decompression in procedure room and early mobilization, what I was talking about, eliminating unnecessary preoperative blood tests, omitting routine group, etc. And here there is operating theater and energy and design, and improving laminar flow efficiency in the aeration of the operating room. Anesthesia, we will talk about it. And product used in surgical care. Okay, so introducing reusable surgical cups, for instance, and here you can see the case study and how the results are measured, all the details. Okay, and this is another case study that I want to show you. Okay, pioneering early mobilization in a cardiac